This is the end product. So these are all ones that I've made. You can make any different shape you want or size you want. Leaves. I like leaves.
Regents Professor Elizabeth Vierling finds inspiration for her artistic pursuits and beyond in the elegance of nature.
One thing that attracted me to plants is that I just think they're gorgeous at all levels. The first time I saw electron micrographs and light micrographs of chloroplasts, and I just said, this is the coolest process I have ever seen.
A University of Arizona biochemist, Vierling is now focused on how organisms, like these Arabidopsis thaliana, respond to stress.
Here you can actually see one of the seeds that didn't germinate in this particular.
She investigates the role of heat stress proteins and their attendant molecular chaperones in supporting vital cellular function.
These proteins are present in all organisms. I was particularly interested in them in plants because, of course, plants are organisms that can't run into an air-conditioned building. They can't go hide under a rock. They're stuck out in the environment. So you end up with a whole set of genetically identical individuals that you can
One particular chaperone Vierling's been working on is present in human neurological diseases.
It's known to accumulate in multiple sclerosis. It accumulates in brains in Alzheimer's patients. The potential to understand biochemically how these proteins do their job could ultimately, in the long term, have implications for understanding how we might intervene in these diseases, or at least understand these disease processes. Have the same sample.
Elizabeth is very much in that camp. How does the natural world work? And all sorts of practical things come out of answering those questions.
Montford collaborates with Vierling, examining how the dynamics of an enzyme responsible for nitric oxide metabolism affect plant health.
Plates, and we can heat stress them this way and then watch how the tissue survives. When I went to college, I wasn't going to be a biologist.
That may be, but early on, she engaged in the natural world.
I loved frogs. I think I caught every frog in this frog pond in New Hampshire more than once. My dad taught me all the constellations, and he just recently sent me some pictures of my mom and I, sort of picking through tide pools.
She shares this love of nature with her daughter, along with a taste for travel.
I've taken her to Panama with me, and she's gotten to live in Europe for a year, and took her to Berlin for a summer. When people ask her if she's going to be a biologist, she says, it's not genetic. So these are the ones you ran yesterday?
Yeah.
My favorite part of teaching is actually having undergraduates in the lab doing research. It's just a lot of fun to see the students take ownership of their projects.
So it definitely goes in at that concentration. She's tough, and she pushes you to achieve the best you can and really go for it.
I encourage them to ask other people to go to other labs, to use equipment in other parts of the university, because I don't know everything.
And she's quite able and really thrives at crossing the traditional barriers that can hold science back. So that broad perspective, I think, is one of the keys. That's one of the things we do well at the university.
The C-terminal tail in this monomer.
She's always looking to introduce different techniques to the lab. It's like, oh, well, so-and-so is trying that, but we don't have the expertise to do it. But let's see if we can establish a collaboration. So I can adjust for it.
She's had over 45 graduate students go through her lab and keeps in touch with many of them.
I think as senior graduate students, we turn into our mentors. I see that in my other friends too, and one of my friends said this to me, even your emails are sounding like Elizabeth's now.
Vierling understands how research works on the highest administrative level. She has been serving as a program officer at the National Science Foundation. And when she's not in Washington, D.C. or Tucson, she's probably attending a scientific conference.
The molecules that are going to be catalyzed can come into this cleft and access. I'm very excited about some of these new directions, some of the more advanced biochemistry that we can do now. How plants respond to the environment, all the way from the molecular level to the evolutionary level, and that's what makes it fun. So I look forward to getting back to that.